Okay, so again, for 10.5, today specifically, we're looking at angles of elevation. On Monday, we'll do angles of depression. For prior knowledge here, we are going to be looking for x. Write an equation to find x, then find it, and round to the nearest degree. So again, this is kind of like our 10.2 lesson, where we had a missing angle right here. And so because we're looking for angles, looking for an angle, that means we're going to use our inverse trig. We're going to have to do like second sine, second cosine, second tangent, okay? All right, so I'm going to have you guys go ahead and try this one, see if you can figure out the angle x. Okay, so again, second cosine, do on your calculator, second cosine gets you the inverse. And then 16 divided by 34, close the parenthesis and press equals. What did you guys get for your answer? 61.9. Okay, but this says to round to nearest degree, so nearest whole number, that has to round up to what? 62 degrees. Don't forget our symbol for units is degrees this time. All right, so this is prior knowledge because we've done this before for lesson 10.2. We're going to need to be able to do this in today's lesson, but we're just going to add word problems to it now. So if we look at our concept here, it says we have an angle of elevation. Angle of elevation is the angle between the horizontal and the line of sight when you're looking upwards. So if you think of like, let's say you go to the gym and you get on the treadmill and it'll ask you for like an inclination. It's like an elevation. You're elevating the treadmill to a certain degree. That's your angle of elevation on a treadmill, okay? And it's always the one looking upwards. So if you think of looking upwards, that means it's always going to be the bottom angle, okay? So angle of elevation, you're looking upwards, and it's usually always going to be the bottom angle on the triangle. So if you look at the triangle, it's going to be the one on the bottom. This is at the top, so that's not the angle of elevation. Because over here, you'd be like looking downwards. Angle of elevation, you have to look upwards. So you're standing here, looking upwards creates angle of elevation, okay? So if I look at my context for this problem, here it says we have a flagpole is 35 feet tall. And then it says from a schoolhouse, the angle of elevation between the ground and the top of the flagpole is 67 degrees. My question for you guys is, how far is the schoolhouse from the flagpole? And we're rounding to the nearest tenth of a foot. Notice my picture has nothing labeled this time. In our last lesson 10.4, we had basically the picture all labeled. All we had to figure out was where does the variable go. In this case, I have nothing on my picture. I had to figure out what my three values are. I have to figure out where does the 35 go, where does the 67 go, and then where do I put my angle, my variable. My variable is how far is the school. This is my variable. How far is the school from the flagpole? So I have to figure out where do I put the 35, where do I put the 67, and where do I put my x. So looking at the context here, it says the flagpole is 35 feet tall. So how do we measure something for height? Is my height, do I measure the height slanted, top to bottom, like the horizontal, top to bottom, right? So the flagpole is right here is 35 feet tall. My 35 goes here. I'm going to put the unit. So this is 35 feet for the flagpole. And it says angle of elevation between the ground. So between the ground and the top of the flagpole, that's my angle. I'm looking to the top of the flagpole and the ground. So that's my angle of elevation. My 67 degrees goes right here. And then I'm asking you guys for how far is the school from the flagpole? Am I asking you how far is the school from the actual flag? Do I measure that way? No, we measure this way, right? How far is the school from the flag? So this is really asking for the bottom part of our triangle, okay? Now that I have my picture, now I can use SOHCAHTOA to figure out sine, cosine, or tangent. SOHCAHTOA. So go label the O, the A, and the H. My angle is here. So across the angle is which side? O, A, or H? O, thank you. Across the 90 up here is H, which tells me then my X is going to be what? A. What letter are we not using? H. There's nothing on the H, so cross out the H's. That leaves us with TOA, which is tangent. So I have the tangent of my angle, which is 67 degrees, is going to equal the opposite side of 35 over the adjacent side, which is X. And then remember, anytime we have a fraction with a variable, we have to multiply both sides by the denominator. So what do we multiply by? X on both sides. So X tangent 67 degrees equals 35. My X is not by itself. How can I get the X by itself? What can we do to get the X by itself? Anybody? Thank you. Divide by tangent 67 to both sides. Tangents cancel, and I get X is approximately. Now that I have my X by itself, now I can plug this in the calculator. So 35 divided by tangent 67, close parenthesis, press equals. So I'll write it out here. Second tangent. Oh, my bad. No, that's not what we're doing. Sorry. I'm thinking ahead. For the calculator, we're doing 35 divided by tangent. You're not doing the second. If you do second tangent, that gives you inverse. Sorry, we are not doing the inverse. 35 divided by tangent 67, close parenthesis, press equals. And what did you guys get for the answer? 14.98?
No, 14.9. Well, it's technically 14.856, so wouldn't it be 14.98?
Okay, yes. So 14.85. So you round it to 14.9. Thank you. And then my, because it says nearest tenth, so it's one number after the decimal, and my units is feet. And don't forget to write a sentence. What did we just solve for? X standard for how far the school is from the flagpole. Okay. So if we write a sentence, we would say the schoolhouse is about 14.9 feet away from the flagpole. Okay, moving on to our next example here, we have a ramp is 26 feet long and 2 feet high. My question for you guys is, what is the angle of elevation between the ground and the top of the ramp? And we're rounding to the nearest degree. So I have to figure out where to put the 26, where do I put the 2, and where do I put my x? Where do I put the 26, the 2, and the x? What do you guys think? It says a ramp is 26 feet long. Do I measure like right here where the crate thing is at? Or do I measure the bottom? Or do I measure from top to bottom? It says a ramp is 26 feet long, right? So the ramp here is 26 feet long. So my 26 feet goes up here. And then the ramp is 2 feet high. Is that going to be the bottom or the top to bottom? Top to bottom. This is 2 feet. And we are asked to find the angle of elevation between the ground and the top of the ramp. So where does my x go?
The angle, sorry.
And the angle, the top angle or the bottom angle? Bottom is from the ground to the top of the ramp. That's the angle of elevation. So my x goes right here. I don't know what x is. That's what we're trying to solve for. Notice this time I'm looking for an angle. So because I'm looking for an angle, I'm going to have to use inverse trig this time. Okay? On the last two examples, we had to do just regular trig because we were looking for a side. But now that I'm looking for an angle, we're going to have to use inverse trig. Okay? We set it up the same though as just regular sine, cosine, tangent. SOHCAHTOA. Go label the sides as O, A, and H, and then figure out if it's sine, cosine, or tangent. Okay, what trig functions do we have? What you guys? So, which is sine, right? I do not have an adjacent side, so we're doing sine. So my S stands for sine. We're doing sine of x degrees equals the opposite side, which is 2, over the hypotenuse side, which is 26. Notice again, I have the x. It's attached to the sine. I can't just say, oh, divide both sides by sine. You can't do that because sine is attached to the x. Instead, we have to do inverse trig to get rid of the sine. Okay? So take the sine inverse of both sides. Sine inverse of both sides. That way the inverse cancels out the sine. And we're left with the measure of angle x is going to equal the sine inverse of 2 over 26. Okay, and then here is where you do the calculator work. So for the calculator, you have to do, this time is where you go second sine. So second sine 2 divided by 26, close the parenthesis, press equal. So measure angle x is going to be approximately All right, go ahead and share with your partner. What did you get on the calculator? All right, what did you guys get for the calculator answer? 4.4, but is an angle, because I'm looking for an angle, we round to nearest degree, which means you round to the nearest whole number. So to the nearest degree, what would a 4.4 round to? Just 4 degrees. Okay? And then don't forget you have to write a sentence. So we would say the angle of elevation between the ground and the top of the ramp is about 4 degrees.